Yeah, hi everyone. Welcome to MuleSoft training session 2. Today we have two agendas. The first agenda is to recap the session 1, and second agenda is related to the MuleSoft training session 2. The first, let us recap the session 1. So as we discussed the introduction of MuleSoft, so such as it involves the data, integrations, communications, so request response, and private public. So these kind of terminologies are very important when it comes to the data communication, right? So if you consider any software application, it's always starts with the user action, end user action. So we developers consider that end user action as a input request, guys. And what is the end of that cycle? So it's a response that we are submitting back to the end user. And always the interaction happens through the APIs. When the end user sends the request, so the interaction generally happens through the API deployed in the servers. So when it comes to data, it will be having multiple types of data. So some of the data types as binary, integer, string, JSON, XML. So we can also consider the some other data types as well, but majorly we are working on JSON and XML. So these are widely used data types when it comes to the data transfers through the APIs. And purpose of achieving data communication through the process of integration. Yeah, to achieve the data communication, we should be integrating with the multiple systems. If you consider a real-time application, it will be undergoing with multiple actions, right? For each action, there will be some kind of processing will be happening at the back end through the APIs. And to communicate the data between different systems, so we are using APIs. If there are multiple interactions, multiple API integrations will be there. That's for sure. What is API? API is just a piece of code which is reusable in nature. And coming to our MuleSoft, we are not going to write the code here, but we actually drag and drop the connectors. So which is going to generate the code, XML code in the backend. And we can call the MuleSoft APIs as a graphical representation of XML codes, guys. And the similar terminology for the API is web service here. There are actually two types of APIs are there, REST API and SOAP API. So what is the difference between REST API and SOAP API? Actually, REST API, so it works using resources, guys. So whatever you are seeing right in the Google, so all these APIs are REST APIs. So let's log into a e-commerce website, Flipkart. So when you log into the e-commerce website here, so this flipkart.com, whatever you are seeing, this is a HTTP URL, right? So this HTTP URL is a request when you enter this in this browser, and when you send the request, so it is actually triggering the Flipkart API that is stored in the Flipkart servers. Okay. So when you enter, the moment when you sense the request, it will trigger that API and it will execute that code. It will fetch this particular page, whatever you are seeing, right? So this page is fetched by the browser itself. As a user, you are sending a request to the API that is stored in the deployed in the server. Okay. Server will respond back to you with this content, whatever you are seeing, the whole page. So this is nothing but a HTML content. If you click on inspect here, so it will give you the HTML code. This HTML code also consists of So this is a beautiful view of this HTML code, right? Because we also have a styling code. JavaScript is there to avoid some kind of intellectual codes here. JavaScript scripting also will be there in this particular code. So styling codes will be referred here. So whenever I'm hovering here, so it is selecting that particular part of the display, because that particular part of the code is representing this particular part of the display here. So actually, server is sending this code, guys, sending the code as part of the response, and browser is beautifying it in this way. So the Google browser is beautifying, Chrome browser is beautifying it, and it is displaying us in this format. What is REST API? I said the Flipkart.com is a REST API. How we can call API as a REST API? Representational state transfer APIs. API means application programming interface. So it acts as an interface between user and the server. Correct, guys? So server is somewhere else. I'm the user. I'm trying to consume the Flipkart API. This particular API is acting as interface between me and the server. It is responsible for fetching, for listening to my request, processing it, and fetching the response from the server. So coming back to our point, see, wherever you are seeing, whatever you are seeing in this display, right? Let me close this inspection mode. So these are all, we called it as a resources of API or resources of a website. Okay. So resources are nothing but the naming representation of a API, guys. That the API can consist of multiple endpoints. Okay. This Flipkart API consisting of these many endpoints. Whatever you are seeing, we call this as a endpoints or resources. We can also call it as a path. Please remember this point: endpoint, resources, path. Going forward, we will be hearing these terminologies so many times. You should be familiar with these terminologies. See here, kilo is there. What does this mean? So it is a resource of an Flipkart API. If you click here, okay, the URL will be changed. See, just click here. See, the URL got changed. Means the after Flipkart.com. So Flipkart HTTPS is a protocol, guys. As I said in the previous sessions, the REST APIs widely follows the HTTPS protocol. This means this accepts request in the form of HTTP methods: get, put, post, patch, delete. We may be having only get access. We may not be having the access related to post. If you try to create your account, in that case, the post will get triggered because you are trying to create a new account, right? When I log in with my existing details, so that will be triggering the get method because that is existing details already existed in the Flipkart database. So when you enter your details and click on submit, what happens? It will trigger the get method. Get method means you have to fetch the details of an existing user. If you click on sign up, so this will create a new user that is not existing in the Flipkart database. In that case, post will get triggered. If you want to update your account in the Flipkart, that means if you did any mistake while creating your account, you can update your account as well. In that case, put or patch will get triggered. If you want to delete your account from your Flipkart, so delete method will get triggered. When you just scroll, when you just going through the website, mostly the get method will only trigger, guys, because get method is responsible for fetching the details from the server. Server means API itself. There the API is deployed. Okay. Server in the server, the API is getting executed, guys. It's a piece of code, right? When it gets executed, it will derive some results. So those results are here. So I clicked on the kilos. So it is giving me grocery supermart store as a resource. Means whatever you are seeing here. Okay. So this will be the job of user UI UX designer. But in the back end, so that is representing the grocery supermarket store resource. So whatever you are seeing, the highlighted one, we only defines whenever we are writing the design of API. Okay. As a API developers, we start gathering the client requirements and then we will proceed designing the API specification. Please remember this point. So whenever you specify the API specification, whenever you design the API specification, there itself, these endpoints are designed. So after initial design, if the API is developed and it is published to the server, and then you got a requirement to add one more resource, okay, that's fine. You don't need to change the design again. You can add the resource directly to the implementation. Or you can update your design accordingly. So here both are different things, guys. Design is different, development is different. Out of the design, we are developing the implementation of API. Out of the API specification, we are going to implement the API. So coming back to our RESTful nature of the API, see, it suddenly changes its state, right? Before it was this one. When you click on the resource, it is changing its state to this one. So that's why the API which changes its states from resources to resources, the API which facilitates us with that feature to change the state of API using resources, we call that API as a REST API. Okay. So all this more is also a resource. So notification preference is also a resource. So the resource is getting changed. Earlier it was grocery. Now it was communication preferences. So what is this push? Maybe this push is a part of this particular resource, or it could be a URI parameter. And after the question mark, whatever you are seeing, we call it as a query parameter. So what is URI parameter and query parameter? You can ask me that. So query parameter and URI parameter are attributes of the input request. You can just consider. What is meant by attributes? That nothing but a metadata, extra information related to the request, right? So if flipkart.com is a request, communication preference will come under the resource and you can consider that as a extra information of that request. Or you can consider push as a extra information for this communication preferences. And T equal to all means it's a query parameter that will be also a metadata information of this particular request. You can click on become a seller. All these are resources, guys. So whatever you are seeing, this is the response that is generated by the API itself, which is deployed in the server. So when the moment when I click on these things, so it is triggering the API that is back behind the scenes. The API get executed and gives the response in this form. So whatever we are seeing here, so this is a UI UX work, but backend code is our work. Okay, so that is our responsible to send the backend response. We can also represent this HTML code in JSON data, or it could be also defined in the XML data. What is JSON data? JSON is one of the data type which generally defines using key value pairs. Consider this HTML as a key, and the value of HTML is head, and head as a key. The value of head is meta. So that is how we define the data in HTML format. And what is XML? XML always consists of starting and ending tag. Here HTML is a starting tag. Its ending tag is followed by the forward slash. Head is also a starting tag and its ending tag is followed by the forward slash. So in between whatever is there, that is appended to the head. That means it is confined to the head part. And we have body. So this is the XML data structure, guys. Or we can also call this it as a HTML. Okay, because it has the format. So it has some boiler template such as dog type HTML. So that's why we specifically call it as a HTML, not XML. XML is also a similar kind of thing. So what differentiate means XML data has XML versions at the top, and the HTML has boiler template like this. So that is our job. We can convert a JSON to HTML. We can convert a XML to HTML. So that is our job. But UI UX designer job is to convert this beautiful code into beautifully viewed picture. Because the end user didn't understand the code, what is behind this one. So this is about REST API. REST API mostly works on the all kinds of data, guys. It works on all kinds of data. HTML, XML, JSON, Java, HTML. So it portable with all kinds of data. But SOAP APIs only accepts XML as input and gives the output as XML. Okay, it is rigid, it is difficult, and it is complex in nature. The SOAP API, it doesn't have state transfers as the REST API has. It cannot, it is not able to transfer its states from one resource to another resource. It always works on the XML input and gives the output in XML only. So SOAP APIs are designed using the WSDL language, Web Service Description Language. REST API designed using RAML, REST API modeling language. So the RAML version, we are going to use 0.8 or 1.0. Okay. So these are two versions we will be using while developing the APIs. So it's just a little introduction. Just remember up to this. Let's move ahead with the topics. And coming to integration MuleSoft API and its advantage. See this point. What is this point is defining here? We can achieve integrations using MuleSoft in APIs. Okay. So why we need to actually integrate different systems? What is the purpose of integrating different systems? So in the previous session, I said that so there will be multiple interactions will be happening between different systems to perform one task. Okay, to perform a task, there will be multiple interactions will be going on in the API, in the mobile in the application. That could be mobile application or web application or Android or iOS. But API is common, guys. Okay. Using MuleSoft, if you are able to build a API that could be consumed by all these applications. A web application can consume the same API that is consumed by Android application, and iOS also can consume the same API. Okay, API is same, but whatever the data we are publishing to the target systems may differ according to the business. That depends on the business. So coming back to integration, as I said, for just a simple ordering a product using a e-commerce platform, e-commerce web application. So multiple interactions, multiple systems required. So when you log into your system, when you log into your business application, so the consumer or end user or customer is going to place an order. If we place an order, means placing an order is information. Where that information is getting, we are getting from. So we are getting from the vendor itself. So the vendor is going to update us with the products, right? So yeah, Flipkart, these are the products I have currently. So you should be dealing with these products and displaying these products in the so the UI, so that the user can order the products. So that information is actually we are getting from the vendor system. So we need to integrate with the vendor system, right? To fetch that particular piece of data. Otherwise, how it possible? And fetching information from the vendor system is like it's frequently changing. It's not a constant one. See, throughout his lifetime of his business, it will not be the same. He can update some of the products into his existing business. He can remove some of the products from his existing business. So real time transaction should be there, because the end user can order a product in midnight as well. So there will be no manual work is uh, encouraged here. Everything should be automated. Everything should be real time. So whatever the vendor publishes, so these are my products. So that could be seamlessly will be updated in the Flipkart UI through our API service. So this will one of the integration. And what will be the another integration? Database integration is the important and common integration happens. Because to fetch the information of a registered user itself, we need database. To check the validity of the user, existence of the user, we need database. Once I log in, once I sign up, my details will be stored in the database, right? So once the details are stored there, so they will be using for the future reference to validate the existence of the user. So once any user submits his credentials, what the Flipkart API will going to do in the backend? So it will be validating his existence in their database. If it exists, so it will proceed him. It will allow him to consume the services of the Flipkart API, or it will just simply you are not existed, your account does not exist. Please create or please sign up. So this kind of user message we are going to display. All things are we itself going to develop using APIs, guys. If the account is not existed, we only display that message, user message. So database integration is common. So let us say if you want to publish some records to Salesforce, in that case, Salesforce integration will happen. If you are generating invoices using the Salesforce integration is must. And Kafka is one of the like real-time integration platform. So it will helps the businesses to achieve the real-time application. Okay, we don't need to manually trigger the API when a specific task is performed. So we can like make use of the Kafka topics to publish the messages related to the API. So related to the request to the MuleSoft. And those published messages are going to process seamlessly using the MuleSoft API and gives the response back to the end user. So Kafka integration is also one of the important topic here. SAP integration is there. So what not? MuleSoft can integrate with n number of systems. You name it, it is there in integration part. So that's why demand for MuleSoft is very high in the market. Because integrations is very important. They are critical while data communication, as data communication is important, right? So integrations are also important, guys, to achieve a business. And it is developer friendly, MuleSoft. Everything is it is providing at one place. You can design the API using the MuleSoft product, that is Anypoint platform. It's a web-based tool. You can develop the APIs using the Anypoint Studio, that is IDE, integrated development environment, similar to the Eclipse. You can also make use of the Eclipse actually to develop the MuleSoft APIs by just downloading the MuleSoft related dependencies in the Eclipse IDE. But widely we are going to use Anypoint Studio itself. The current Anypoint Studio version is 7.x. X means that could be the minor release or patch release. Okay, 7 is the major release. If you are talking about the work, hello guys, hello guys,
Yes, yes, Akash. You're audible.
1 second, guys. So as I was saying, MuleSoft is a developer friendly. It provides Anypoint platform, Anypoint Studio, and Anypoint platform has uh, so many features in it to design the API, to deploy the API, to manage the API, to publish the API. So to design the API, Anypoint platform provides Anypoint design center. To deploy the API, runtime manager. To monitor the API, Anypoint monitoring. To publish the API to the marketplace, Anypoint exchange. So we can also apply the security policies to the API because all APIs are not public. Some of the APIs could also be private, which are mainly the APIs which are mainly connecting with the raw data, means underlying systems. For example, if you are connecting to the Flipkart database, there you will be able to access all the Flipkart user details. So their uh, phone number will be there, their email IDs will be there, right, guys? So those are sensitive information which are not like public purpose. Those are not uh, like they need not to be exposed to the public. So those kind of APIs which are interacting with the underlying systems are we have to apply the security policies on those. MuleSoft itself provides a feature to apply the security policies. So that is a quick recap of our agenda one, that is session one. Let's go for our agenda two, that is API-led connectivity approach. So before going to API-led connectivity approach, let me clarify some things, guys. So we know how important the integrations are. So why we need to integrate? Because in real-time business, when business is going on, when the service is getting consumed by the end user, there may be like we may be dependent on another system. So let's say if you are dependent on the database to store the details of registered user in the Flipkart database. Okay. So let's to when to store the your details into the database. So database DBMS is important. What type of DBMS one is going to use? So there are so many DBMS are there. Oracle is there, MySQL is there. So MS SQL is there. So these are different DBMS are there, right? So one can use any of this. So for each and every DBMS in MuleSoft provides only one connector. That is a appreciating thing. It's a great thing, right? So only one connector for all the DBMS. So using one connector, we can change the configuration type. Here we will be having the configuration type. So what type of DBMS you want to select, you just need to select from the drop down. So it will the drop down is going to consist of these details only. It will also consist of a generic connection. Generic connection will applies if you like it applies for all the DBMS. You just need the database URL to connect to that particular database system, right? So this is integration is when
when it comes to integration, we are actually establishing the connection, guys. Establishing the connection to that system. Let's say database is Oracle database is your main source to fetch the details related to the user, details related to the product, details related to the vendor, detail related to the payment gateways. So Oracle may be your main source for your data. In that case, you have to establish the connection between the MuleSoft and Oracle, right? So to establish the connection, we have one connector. So this in this connector, you are going to fill up this connection details. So those connection details we call it as a configuration. Connection details are nothing but configuration. Okay. So for example, for Oracle, the connection 1 second, guys. Give me a 1 second. So the connection details related to the Oracle, MySQL, and MS SQL generic. So those are like slightly different. Okay. So this will be consisting of schema name. The one of the configuration is type of DBMS you are going to select. The username, password. Okay. And these credentials are environment specific. Okay. For lower environments, that lower environments means dev environment, QAE, test, SIT. So for these environments, also for each environment, these credentials are different. For production, these credentials are different. And the credentials related to the production environment should be confidential. They could not be shared within the developers also. Okay. So those should be protected. Those credentials should be protected. And for Salesforce as well, we have the configuration. To establish the connection between MuleSoft and Salesforce, we have to enter its connection details. So that we call as a configuration. For Salesforce, we have a Salesforce URL, username, password. So these are some of the basic credential details one should be using while connecting to the Salesforce. Similarly, for Kafka, to establish connection between Kafka, MuleSoft and Kafka, so we will be having broker URL, Kafka broker URL. We will be having receiver topic on which the messages are going to published. For example, if you are working on loan web service, when the user is accessing the loan web service, he wants to submit its loan application. If he is submitting its loan application consisting of details such as applicant name, his personal details, or his loan required amount, his account related information, right? So when the moment when he click on submit, so that will be considered as a Kafka message. So that Kafka message is going to published into the receiver topic. So from where the MuleSoft is going to pick up that message and start processing that request. So receiver topic here, you can consider it as a source. So where the end user is going to publish the message. And we are going to pick the message from this receiver topic. Means the Kafka is always, it is in live, always in live. Okay. So we have some kind of connection such as heartbeat interval. Okay. So this heartbeat interval in Kafka specifies the connection establishment that is in the environment. Okay. So broker URL, receiver topic. One more important is consumer group. Consumer group means the group which is consuming the messages. and number of parallel consumers to implement concurrent processing, parallel processing. Okay. So this is about some kind of integrations, guys. So to establishing integrations with this database, Salesforce, Kafka, we have database connector, Salesforce connector, Kafka connector. And these connectors requires two things. One is configuration, that is called connection details. And other one is dependency. Please remember this point as well. Dependency means each connector has their own dependency, guys. What is this dependency? This is a snippet. Actually, it can be represented in the form of XML format. So I'm going to write that XML code here. So it will consist, as I said, the XML code consists of starting tag and ending tag. It will consist of group ID, artifact name, version of that connector. So this is how we define the dependency of each connector. Okay. So for Salesforce, for Kafka, so for all these integration connectors, we have two things. One is configuration, other is dependency. So what is this dependency? One more thing I need to add. Actually, we are working on the Mule 4 projects. Mule 4 projects are Mavenized projects. Okay, they are Mavenized project means the project which has a POM file, project object model. So POM file generally consists of the list of dependencies. Whatever the API is using, right? The connector is going to download behind that connector, the dependency is there, and Maven is used to resolve the dependencies during runtime. Means when you build the API, so it will going to download the artifact. So if you are establishing a connection, Oracle connection, so Oracle related data, Oracle related module, or Oracle related artifact. So these you can call any of that. Okay, drivers, Oracle related drivers. So this information is going to download by the Mavenized MuleSoft into the local Maven repository. So what is repository? Repository is a storage place, guys. When you download files, so there will be storage place. And similarly, in MuleSoft, to download the file, to download the connector related information. So generally it is downloading the connector itself. Okay. So dependency will add the connector to your MuleSoft API. When you add this dependency to the POM file, when you save it and deploy, when you save it and build it, the MuleSoft will connect with the repositories, external remote repositories, and download the connector from there and add to the API. And the details related to the connector is getting stored in the local Maven repository. So whatever you are writing the code, right, that code is also stored in the local storage only, right? In the same way, to handle the dependency related storage, that is going to create a folder called .m2. We call it as a Maven repository. For Mavenized projects, for Java projects, so .m2, we will be knowing that. We will be using, so it is automatically created by the environment, project environment. So for Salesforce as well, we will be having dependency. So depending on the connector, the group ID, artifact name, version will be changing. If see, Oracle is going to publish the updates regularly. So 2 years back, you are using Oracle connector. So MuleSoft is having the real-time connection with the repositories, right? it will connect with the Oracle repository and download the latest dependency of that connector. Okay, 2 years back the version may be different, but now the version gets changed. So when you try to build the API, so it will ask you, the MuleSoft project will ask you, will can I update the modules? If you click on yes, it will update the modules to the newer versions. So that is the point of dependencies. That is the point of Maven projects. Otherwise, we will be sitting and manually updating the dependencies. So the downgraded disadvantage of downgraded version. What is the disadvantage of downgraded version? The disadvantage of downgraded version is it is more sensitive. Hackers can easily hack your API and steal the data. So the updated version has the patches to the fix. So that's why resolving the dependencies real time is very important. So that is up to integration of connectors, and some connectors are there which don't have the dependencies. Okay, so those we will be discussing. And let's come back to API-led connectivity approach. You will be understanding why I explained the integration part first. See, this one we have already discussed, recap of session 1. So API-led connectivity approach. This is how the API-led connectivity approach looks like. It is a 3-layer approach, guys. As I said in the previous session, it's basically a multiple interactions, means multiple API integrations will be happening. Multiple API integrations means multiple API network, multiple APIs. Multiple API means API network only. So what you are seeing here? It is nothing but a API network. So it is forming a web-like structure of the APIs. So all these are MuleSoft APIs. Whatever you are seeing, all these are MuleSoft APIs, blue color logos. So what is this? So these are end users or customers who are consuming our software services. And what is this below? So these are underlying systems. Okay, these are end systems, underlying systems which has sensitive information. These consist of raw database. Raw data means the data which is on which the business is working. See, here this approach is explaining 3-layer APIs. One is system API, process API, experience API. System APIs means these are all comes under the system APIs. Process API, these are all covers under the process APIs. These are all covers under the experience API. And to perform a action, to perform a task, so these many APIs interact depending on the input request. So what is the user is sending the request. So depending on that request, these are all interacts with each other. Coming to system APIs, okay. Here, system APIs are actually integrating with the underlying systems. They have direct connection with the underlying systems. They have direct access to the sensitive information. So when a API is having a direct access to a sensitive information, that means the API should be protected. It should not be for public use. It should not be exposed to public. So those APIs are very protected in nature. We have to protect this API, system API, right? In order to protect the sensitive information. See, this system API credit score is connecting with the credit bureau database. Documents are directly connecting to the document system. And e-signature is also directly connecting with the DocuSign database. Loans is connecting with loan originating system. Borrower web service is connecting with mortgaging service. And borrower data is stored in 3 different databases: Oracle, MySQL, IBM database. Okay. See, if this system API is connected with the sensitive information, this should be protected. That is obvious. And what is process API? So process API, as the name suggests, it is processing the data that is coming from the system API. What is data processing, guys? The examples of data processing in the previous session, I explained that. So examples of data processing such as converting the data from one form to another form, that will be one of the simple data processing. Or extracting the data from the DB. It is also a data processing. Or filtering the data, arranging the data. All these are data processing. So behind the data processing, we have to write logic. So that logic is data view logic. Okay. As I said, we are going to develop MuleSoft APIs graphically. We are going to drag and drop the connectors. That's for sure. But to process the data, we have to write the code, actual code. So that code, MuleSoft provided a data view programming language. Data view transformation language. So that's a data transformation language, which we are going to use to process the data wherever it is required. Okay. Please note this point, wherever it is required. See, for example, originate loan. Okay. If a customer is submitting his application, the first thing we will be validating his candidature. Means he's like, is he valid, or is he like able to get the loan or not? So these details we will be finding out. So to find out his eligibility, we will be going to know his credit score first. And we will be storing his documents in this document database using this document API. We will be collecting his signature. We will be checking his previous loans. We will be checking some other information related to that. So the person who is taking the loan, we call them as a borrower. And we will be storing his data in our database. Right? So to perform all these operations, so when he submits the loan application, so the original loan might consist of some kind of processing. So this originate loan may be connecting with the get loan status API. Okay, here integration is happening. Integrating is happening with this get loan status. So to integrate originate loan with the get loan status API, the connector we are using is HTTP request connector. We can also call connector as a component. So HTTP request connector, we will be giving the details of this API. That's it. Each API, coming to the basics again, each API is represented by its name. As I said, API has multiple resources or endpoints or path. So each endpoint has its own name. We saw right in the first example. So these APIs also have their endpoints. And each endpoint is meant for a specific task, performing a specific task in real time. So those endpoints has their names. You just need to give that name here in originate loan. If originate loan is connecting at a particular time, at a particular instance, if originate loan is connecting with the get loan status, you will be just giving the name of the get loan status in originate loan. So that's how integration happens. And adding to this, actually, when you are calling a API, So HTTP URL plays an important role because the HTTP URL is explaining the request information, right? So starting from our first example, it has showing https flipkart.com. Means this flipkart.com is this API, sell online, is the endpoint representation of the API, is one of the endpoint representation of the API, Flipkart API. And this is getting deployed in this Flipkart servers. So seller.flipkart.com is a domain, guys. It's a server domain representation of a server. HTTPS means it's a protocol that is followed by this API. And sell online is one of the endpoint of that API. And this will be the request resource, request query parameter. Means simply I can say HTTP URL explaining the request in technical terminology. So you should be giving the HTTP URL of get loan status in originate loan in order to integrate get loan status with originate loan. So why we are integrating get loan status with originate loan? To get the loan status, if the candidate is having a pre-existing loan in our bank, so that is our job to check his loan status first before proceeding with the loan, current loan. So to check the loan status, we have a separate API. So that API is responsible for getting his loan status and sharing the loan status with this originate loan. So if the loan status is active, and it is again client requirement. If loan status is active, our client, our bank is saying, don't process the loan, then we don't process that loan. We'll just send the response back to the user by saying you have an existing loan in our bank database. So you should need to close that particular loan in order to get a new loan. So this kind of user message we are going to show to the end user. So what the logic behind all these things we are going to develop using the API. We are going to write the logic using data view. So what kind of processing is happening here? We are taking input, we are integrating with get loan status. Whatever get loan status is getting the response from the credit score or loans department, that response is sharing with the originate loan. On top of this loan, we are deciding whether to give, whether to process the loan or whether to reject the loan. We can write a if else, simple if else logic. If loan status is active, reject the loan. That message will populate in the user UI. Else means loan status is inactive. In that case, we are going to proceed the loan. So to proceed the loan, then the next step will get triggered. It's a kind of algorithm. Okay, if you are following the algorithm, step by step will be there. Step by step action will be explained in the algorithm. Same way. So where these algorithms are defined in the client requirements. So to design the API, we should be going through the client requirements clearly, and we will be connecting with the clients in order to like resolve the queries there with them itself. So what are the client requirements are generally provided to us? So functional specification document. So this is one of the client requirement we will be getting. So client requirement generally stored using the enterprise tools such as Confluence. So they can be stored using a PDF. They can be stored using the Excel sheet, spreadsheet. They can be stored using the Word document. In order to like understand the client requirements, we have to go through these resources. Once you understand the client requirement, then you come up with the design, which replicates the algorithm kind of thing. So then you start developing, right? So, okay, the client status is in loan status is inactive. Then proceed to get borrower loan history. So this API gets triggered by the get loan status only. Okay, it also interact with the borrower loan history, and borrower data is initially like we are going to validate checking the existence of borrower using this API itself. because this API is interacting with this system API. So in this way, the process API at each stage, we are processing the data that is collected from the system APIs. So process API should also be protected. It also not be meant for the public use, because it has some kind of results which are not filtered. Means this originate loan is going to trigger some other steps. Once if you find the loan status as inactive, the some other steps may include getting his credit card report. So to get its credit card report, we will be connecting with the credit score. This will be connecting with the credit bureau database system. And finally, experience API. So whatever the output coming from the process APIs, so this will be going to the experience APIs as an input. And in experience API, little data transformations are acceptable. Complex data transformations cannot happen here. Okay, converting XML to JSON, JSON to XML, depending on the client requirement again. So what this system is accepting. If the mobile, we just saw, the mobile end user is accepting the HTML code, right? So you may be required to convert that XML code into HTML code and send to the mobile app. So that kind of data processing happens in experience API. And these APIs are public, guys. Okay. These are directly exposed to the end user. They can directly consume these APIs. See, for customer experience means they can be having customer supported feature here, and associate experience here is there. For payment related thing, we also have one API. So this will be connecting with the payment gateways, credit card payment gateways, debit card, or UPI payment gateways. So that kind of integrations happen because those are all third-party vendors itself. So we are integrating those systems with our MuleSoft to provide the payment feature to the end user. And default, maybe this will be notifying the end user regarding his application progress of application. If the application rejected, the end user should be notified. So this API may be connecting, all these are interlinked with each other. Okay. So this can all be integrated. This can all be shared the data across each other. And default can be get the information from the originate loan, whether the loan is get processed or rejected. If rejected, it will be notified to the user. If accepted, okay, it can say it will take 1 or 2 business working days to process your application. It is in progress. So we are going to implement email connectors to notify through emails. We can implement through SMS. So for every action that we are seeing on our daily regular lives, so those are generally developing using the APIs. So to perform a single task, there could be multiple interactions happening between the APIs. And what is the purpose of API-led connectivity approach here? Reusability of APIs. So this is the purpose. You are reusing the API again and again. As I said, API is a reusable piece of code. You can make use of it any number of times. In OOPS programming language, object-oriented programming, we have a concept called classes and functions. What is the point of function? So that can be reused again and again. Similarly, API is also a reusable piece of code. So that is one important feature of API-led connectivity approach to implement the reusability, to leverage the reusability concept. One more thing, guys. All these APIs, for example, system APIs, all these APIs have their own domain APIs, and process APIs have their own domain APIs. Experience API has their own domain API. So what is domain API here? Domain API is an API which is not having any flows or any logic related to the data processing, but it acts as a shareable project. The project which consists of the shareable resources. You can call the domain in that way. Because this system API, if this system API has one common domain, means in that common domain, you are storing all the connection details at one place. And those common details, common connection details getting reused again and again in these APIs. See, this borrower data is connecting with the three databases, Oracle DB, MySQL, IBM database. Means we have three database connectors, three different configurations. Correct, guys? So here, whenever you are integrating with the database, I said you have to remember 2 points. One is connection details, that is configuration. Other one is dependency. So the dependency for the database connector is common. So what is the point of storing the database dependencies? Here in this API. If other API as well, if for example, let us say read borrower history is connecting with the Oracle database. Okay. So read borrower API is storing the dependency configuration, and Oracle database also storing the dependency on configuration. So that is a redundant piece of code. Means you are storing the same piece of code again and again. You should be able to reuse that. So to reuse that, store that common dependencies in domain project. In domain project, we will be storing the connection details. We will be storing the dependencies of the modules which are getting used in this system API, and those dependencies and the connection details which are in the form of configuration properties. Means, for example, the connection details schema. So this schema you can be storing using a configuration property. Let us say Oracle.schema. So Oracle.schema may be having some value. So this you can consider it as a configuration property. So this, or same for Oracle.username, Oracle.password. Applies for MySQL, applies for generic. So this we call it as a configuration properties. These properties are getting stored in the domain API. So domain API is storing all these configuration details. If more than one API is making use of the connection details, so then in that case, you will be simply connecting to the domain API and reuse that particular piece of code in that particular API. For instance, borrower data and borrower web service is connecting to the Oracle databases. Okay. So as we have stored the Oracle database dependency and Oracle database connection in domain project, and these system APIs are integrated with the domain API, that means borrower web service can be used the dependency and the configuration that is getting used by the borrower data API. Okay, same dependency, same configuration getting used in two APIs. That is what point. That is the point I want to make. Means connection details and dependency also getting reused using the domain API, guys. Please note this point. And for process API as well, experience API as well. So for each layer, we have three APIs, three domain APIs. So that is your choice. If you want to keep one API, single domain API, that is getting shared across all this process experience system, that's your choice. And one more benefit here. So because of differentiating the API for a specific task, so it is helping developer to debug whenever error occurs. So if these APIs are deployed in production environment and the consumer is accessing our software services, and this read borrower is getting it is not up and running. Okay, it is not running in the production servers. Then in that case, at this particular instance, whenever we are trying to read the borrower details using the borrower data API, okay, so there the read borrower API will go into throw the error. So as this functionality is differentiated and put in the read borrower API, that means in server logs, we will be able to find out easily. Yeah, by just going through the logs, yeah, the error exists at this particular read borrower API. We don't need to care about all other APIs. We just need to focus on the read borrower API, and we need to check, we need to debug using the sample input request, which is actually mimicking to the end user input request. And using that request, you will be triggering this read borrower API and check its performance. As this API is in debug mode, as a developer, you will be easily find out the bug. You will be easily find out the defects, right? So that's how diagnosing the defect is happening in using MuleSoft, using the debugging. Means if software service is not working, you don't need to worry about all other APIs, because there could be hundreds of APIs, hundreds of interfaces. We can call this as interfaces. So you will be taking ages to debug that issue. That's not the desired way of development. So the desired way of development is to implement the development in order to like resolve the debugging issues, finding out the errors. So this explanation covers most of the part, guys. So whatever I have explained, the same thing present here. Process API as well and experience API as well. See, in process API, I added one example for the aggregation here. So member ID and credit ID. So my point is here to define the loan ID, I was making use of member ID concatenating with the credit ID. Means if a customer applying for a loan, if he is applying for a loan, he has its own member ID, right? Or account number. And he is also having its credit score information. So the information which is related to his credit score, that is having a unique identifier. So just concatenate those two identifiers and create a new identifier, unique identifier. We call it as a loan ID. So we can simply, what we are doing, we are aggregating two pieces of data and we are forming a loan ID. So that is getting stored in all these APIs. Okay. So to originate loan, we should be first, what we need to do? We need to create a unique identifier, right? When you get a job in your organizations, what is the first thing they will be going to give you? Unique ID. In the same way, when a business process triggers, unique identifier is very important, guys, to uniquely identify the actions, transactions. So that is what we call processing, data processing. One of the data processing is data aggregation, data splitting, data conversion, data arrangement, data filtration. Okay. So to process the data, we are having these many connectors. Okay. So as I said, to integrate the REST APIs, we are having HTTP request connector. To integrate the database, we are having database connector. To integrate Salesforce, we are having Salesforce connector. For Kafka, Kafka connector. For SOAP web services, web service consumer connector. So to process the data, we are having these many connectors. Set payload, transfer message, What is flow reference? Flow reference is to connect with another flow. Set variable is to define to declare the variables. HTTP request connector is to connect with the HTTP REST APIs. And experience API is meant for the end users, where we are going to publish our final responses after doing small data transformations, like converting one form to another form. And we also discussed the API-led connectivity approach details. And coming to this point, source process error handling. Okay, what is source process error handling? Actually, we are developing the APIs in MuleSoft using flows, and the flows has 3 parts. Those 3 parts we call it as a source process error handling. Okay, to listen to the end user request, source part will be triggered, and after listening the input request, to process the input request, processing part will be triggered. And if there are any errors in the source part and process part, error handling part will be triggered. So to facilitate these 3 things, we are going to use flow in MuleSoft. Okay, to listen the input request, one should be using HTTP listener, Kafka message listener, scheduler, on table row. So these are some of the source connectors. Please remember these points. In interviews, they are going to ask. And web service consumer is to connect with the SOAP web services. So coming to client here. So who is client? Client could be a web application. Client could be a mobile application, that could be Android or iOS. Okay. So when an end user accessing our web services, accessing our software services through his mobile or any web application, so the moment he sends a request, so it will be in the form of HTTP URLs. HTTP URLs defines the input request, guys. It consists of request types such as query parameter, URI parameter, payload related information. Payload related information means it's a message, guys. It's a message. Okay. And payload, it changes its nature depending on the processing connectors. I will be explaining in later sessions. Coming back to our point here. So client sends request. The API which is deployed in the server is going to execute in the server. So that means once the server gets executed, the API which is deployed in the server gets executed, it is going to give some results. So that results, we call it as a response. That is going to give back to the client. Okay. And the response could be success, failure. Both needs to be considered as response only. Okay. And what is mule message? So whatever the input request is coming as, right, we consider that as a mule message. Okay. So the mule message has 2 parts. One is payload and its attributes. That's it. Payload, we call that as a body. Body could be in different data formats: JSON, XML, CSV, Java, that could be in any format. And what is attributes? Attributes are 3 formats: query parameters, URI parameters, headers. So generally request we can define in four types. One is body, that is we call it as a payload. That could be of different data formats: JSON, XML, Java, CSV, right? Another one is attributes, that is query parameters, URI parameters, headers. So query parameters defines by question mark. Whatever after the question mark, we call it as a query parameter. URI parameter defines by a specific path. Means if you have a resource, let us consider the loan application itself. So when a user is submitting his loan application, okay, on top of the loan application, there could be a connected resource, such as reading the borrower data. So we can consider that reading borrowed data is a URI parameter. And what are headers? Headers are information. So that explains about the host, port, authorization, user agent. Means these are some details related to the input request only, right? See, I'm consuming the Flipkart API, which is deployed in the Flipkart server. So the host and port are related to the domain. So that also comes under the request. And authorization. Actually, the Flipkart API is public. There is no authorization. If you have any authorization, authorization related data will be stored in the headers. What is user agent? So from where the request get triggered? Is it from the Chrome or is it from the mobile app? So that kind of client related details. And this will be the data view syntax to fetch the information from query parameters, URI parameters, headers. Dot is the data extracting operator. You are extracting the query parameter from attribute. You are extracting a specific query parameter, that is Q, from attribute. There may be a chance of multiple query parameters. So specific query parameter is extracting here. And here we are extracting all the URI parameters, not a specific one. Here we are extracting specific header using this syntax. Attributes.headers will list out all the headers such as host, port, authorization, user agent, path, etc. But this will fetch specific header, that is host. And HTTP URL looks like this, right? We all know this. It's a HTTP protocol, that is the protocol which is followed by our API. And this API is deployed in localhost on the port 8081. It has the resource as session details and endpoint 1, and query parameter as Q, which consists of the value as session 1 det. So we call the request as HTTP URL. HTTP URL actually defines the input request. Along with this HTTP URL, we also have payload, and the HTTP URL itself consists of attributes sections such as query parameters and URI parameters. And one more header is there, localhost 8081, and the protocol it is using. So this will comes under the headers. This will comes under the URI parameter and resource path. This will comes under the query parameter of the input mule message. So mule message is basically a payload and its attributes. Attributes means metadata information about the payload, guys. When the mule message enters into the MuleSoft API, there comes variables. Means variables also gets added to the mule message. Outside of the MuleSoft scope, only these two will be there. When it comes to the MuleSoft, variables also gets added. If you explicitly declare the variables using the set variable component. If and only if, right? If and only if you are declaring the variables using set variable component, then only it will be added to the mule message. Otherwise, it will not be there. The count of variable will be 0. This is about mule message. We know this HTTP request methods. These are part of the HTTP protocol, and HTTP responses also are there. I forgot to add those. HTTP responses such as 200, 400, 500. 200 is for successful response. 400 is for client error response. 500 is for server error response. And what is server? Server is it's nothing but a storage place where all the APIs are getting deployed. And we are frequently interacting with the server. The clients are interacting with the server. Okay? Means the API is deployed in the server. The API is getting consumed by the n number of consumers on daily basis. That is what we call as a traffic. Means so many users are trying to consume the API which is deployed in the server. Sometimes we will be trying to consume government websites. We will be listening to some kind of things like the website got crashed due to the traffic. Means a huge number of customers got trying to consume the API government website that is stored deployed in the server. Means the server is not able to handle those many requests. It is not able to process those many requests at that single point of time. So that's why server gets crashed. So that is where load balancing concept comes into picture. Means if you have two portions of a server, means the load balancer, what load balancer will do? It will balance the load on the server. Means if a server one is accepting 500 requests per minute, if at that particular minute, if you are getting 600 requests, it will route those extra 100 requests to server 2. So that is the job of load balancing. Okay. And coming to this point, generally server is a storage place where the APIs are deployed in the form of executable jars. What is jar? Jar is a Java archive. It's nothing but when you write a code, when you develop a API, and when you build it, it generates a jar file. Please remember this. Means that jar file is nothing but an archive. It's a zip file, okay, which consists of all the information about the API, all its information such as integrations, all the data processing logics, all the error handling logics. Only this jar file, which is not more than KB. It is just a KB file. It's stored in the KB storage. But your actual API is take some MBs. So if you deploy that, if you build it, after successful build, it is going to generate an executable jar. So that jar is we are going to use to deploy in the servers. These deployed executable jars are executed whenever the client sends a request. That is what I'm saying from the start itself. When the client sends the request, the API is a code which is getting executed in the server and gives the response back. And there are like types of servers are there. One of them is on-prem server and cloud servers. So on-prem servers are generally a group of servers owned by the organization. If you are working for an organization, then they might be having their own servers. And MuleSoft provides a cloud-based server, that is Cloud Hub. It is related to the AWS, and which are leased to organizations on subscription basis. If an organization is using a MuleSoft, if they bought a license, MuleSoft license, means they have subscribed to the Cloud Hub servers. They are eligible to use the server for that particular specific period of time. Okay. What is build and deploy? As I said, when you develop an API, you have to, it is nothing but a set of instructions. It is nothing but a piece of code which needs to be executable at the end of the day. So that is for sure. And we write a code means we develop a API, which is a code. We build it to check for any compilation errors. What is compilation errors? You are compiling the API. You are building the API. So there are two types of errors, guys. One is compilation errors. Other one is runtime errors. I will tell the difference. Compilation error means actually we have completed the development of API. So when you build the API, it will try to download the artifacts from the repositories. That is one thing happens while building the API. And that is a basic thing, because to establish the connection, downloading the artifacts from the repositories is important. And second thing, it will check for the syntax errors. And third thing, it will establish the connections. So these are the basic things happens when you build the API. Once you build the API successfully, that means it is ready to get consumed by the end user. Okay. When a user sends a request, which is deployed on the local host, means the API will going to execute now. So when during the execution of the code, if you face any error, we call that error as runtime error. During the building of the API, means while generating the artifacts, while downloading the artifacts from repository, while checking the syntax errors, if you found the error there, we call them as a compilation error. Okay, compilation errors are static in nature. Runtime errors are dynamic in nature. Means when a request comes into picture, there may be a chance of getting some kind of runtime errors. Means there may be some kind of data conversion errors will happen. If you are converting null scenario errors will happen. Means if you are trying to, if users is intended to submit a data, but he does not submitted that data. If he is not submitted that data, that will be considered as a null, and you are trying to convert that null into some other data type. So null conversion error will be get into picture, that we call as a runtime error. Means when running the code, when executing the code, if you get the error, we call the runtime error. Execute that code to get the response from that piece of code. Okay, these two are also done. What is URL API execution? As I said, URL explains the input request. API is represented by its naming convention, that is resource or endpoint or path. What is execution? Execution means executing the API, executing the executable jar that is deployed in the server. Flowchart and API design. API design is nothing but a flowchart, guys. Flowchart defines step-by-step process of the business flow. Same way, API design mimics the flowchart. We are going to design the API using Anypoint Platform Design Center, which is provided by the MuleSoft itself. What is actual implementation? Once the flowchart is completed, we are going to actually write the code. In the same way, once the API design completed, we are actually implementing the API using flows in Anypoint Studio. It is also provided by the MuleSoft. Okay. To deploy the code, to execute the code, we are going to use MuleSoft provided tool, that is Runtime Manager. So that's it, guys. We have successfully completed the session. Any queries?
No, Akash. Thank you.
Okay.